Hi dear, this is a continuation of types of chemical reaction. Now we'll see the double displacement reaction. So in the displacement reaction, that means in a single displacement reaction, based on the reactivity of the metals, the elements will displaces from one displaced. Okay. So in the case of double displacement, we will not consider the reactivity of the elements. Okay, it is only based on the exchange of the ions, that is positive and negative will exchange. Okay, so we'll see how it happens. For example, so two compounds, right? This is one compound. Take this is a positive cation and this is anion negative. Okay, and again this is another compound. This is your cation, this is your anion. So in the double displacement reaction, this cation will exchange to this place. So the only cations, either cations will displace or anions will displace. So I am going to displace these cations. So this will come here and this will goes here, right? Okay, now it is also neutralized. This is positive, either this is negative, this is positive, negative, you will get a neutral compound. Either this will happen or we can exchange the anions. So this is your anion, this anion will displace to here. So this will come here and this will come here, and two compounds react and displace displace their ions, and newly two compounds will be formed. Okay, clear on this? So that is two compounds react with each other and exchange their ions, okay, and form two new compounds. Clear on this? Okay, so we'll see some example. Silver nitrate plus sodium chloride, right? So silver Ag plus and NO3 minus, Na plus and Cl minus. So what will happen? This cations, either the cations will displace or this anions will displace. Okay, so we'll check displace this cations. Okay, so this Ag will combine with this Cl minus. Okay, so silver chloride plus sodium, this sodium will combine with nitrate. So sodium NaNO3, sodium nitrate. Okay, silver nitrate is a compound and sodium chloride is a compound, react each other to form a new compound. What is a new compound? Silver chloride and sodium nitrate. So everything is balanced here. Okay, likewise here, first we will write the charge. Okay, Na plus OH minus, H plus and Cl minus. Okay, this cations will displace this cation. So this cation will combine with this anion. So you will get sodium chloride plus this cation will combine with this anion. So HCl. Sorry. This H will combine with OH to form H2O. Sorry. Okay. So this is actually this is otherwise called as neutralization reaction. This is a base, this is an acid. It reacts together to form a salt and water, NaCl plus H2O. So one Na is one Na, Cl, one Cl, one 2H, 2H, 1O, 1. So it is otherwise called neutralization reaction. Neutralization reaction. Okay, next, lead nitrate reacts with potassium iodide to form, what are the compounds? This is a compound reacted with this compound to form two new compounds. So we'll write the charges first. Pb2 plus NO minus, this is potassium 1 plus and iodide 1 minus. Okay, so we'll exchange the cations. Okay, this will, potassium will combine with this nitrate. So KNO3, and this lead reacts with the iodide, means PbI2 based on the valency. If you cross this, PbI2, potassium nitrate plus lead iodide will be formed. Okay, you know the color of this lead iodide, right? It is yellow in color. It will precipitate, right? So we can say this is a precipitation reaction also. Precipitation reaction. Okay, now let's write the balanced equation. 2 iodine 2 is here, so we'll put 2 here. It becomes 2i, but it becomes 2k here. So to balance this, we'll put 2 here, 2 potassium and 2 nitrate. 2 nitrate is there, 1 lead is 1 lead, 2 nitrate 2 nitrate, 2 potassium 2 potassium, 2 iodide 2 iodide. Okay, clear on this? So this is also called precipitation reaction because this is lead iodide is yellow in color and it will precipitate, it settle down. It is yellow in color. It is also otherwise called as precipitation reaction. Clear on this double displacement reaction? Next we'll move to the last reaction, that is your redox reaction. Redox reaction. So redox reaction means what? Both reduction and oxidation taking place in the same reaction. Okay. So first we'll see what is meant by oxidation and what is meant by reduction. Okay. So here oxidation, the name itself says it is oxidized. So addition of oxygen. Okay. What is that? Addition of oxygen. Addition of oxygen means, that means what? Oxygen is added means it will, we can say in other words, it's a removal of hydrogen also. Okay. Likewise reduction means addition of hydrogen, otherwise we can say removal of oxygen. Okay, so in we can give a explanation for oxidation in terms of metals also, metals, non-metals in the electropositive or electronegative. So, okay, addition of non-metal, addition of oxygen means that itself it says that it is a non-metal. Okay, addition of non-metal or electronegative elements. What is this? Addition of non-metal or electronegative elements is called oxidation. We can also say here removal of, addition of non-metal means what? Removal of metals. Removal of metals, or addition of electronegative means here removal of electropositive elements. Clear on this? Oxidation, addition of oxygen, addition of non-metals or non-electronegative elements. Okay, the opposite of removal of hydrogen, removal of metals or electropositive elements. Likewise reduction means what? Addition of hydrogen means addition of a metal or electropositive elements. Okay, addition of metal or electropositive elements means what? We can say it in other word, removal of non-metals, okay, or electronegative, removal of electronegative elements. Okay, clear on this? So in other words also we can explain what is oxidation. Oxidation is a loss of electrons. Oxidation or loss, oxidation, loss of electrons. Okay, here reduction means receiving of electron. The RR receiving, that is gain of electron. Okay, So now you understand what is oxidation and reduction. Okay, in all respect we have seen. Oxidation means we can say addition of oxygen, we can say, or we can say removal of hydrogen also. Okay, or in terms of metal, non-metals and electronegative and positive. Oxidation means what? Addition of non-metals or electronegative elements, or removal of metals or electropositive elements. Likewise, excuse me, you can say reduction means addition of hydrogen. In other words, we can say removal of oxygen, or we can say addition of metals or electropositive elements. Otherwise, we can say removal of non-metals or electronegative elements. Okay, a reduction is otherwise called receiving of electrons. Okay, you will see some example, then we'll move to the what is reducing agent and oxidizing agent. Okay, copper oxide plus hydrogen gives copper plus water. Okay, so we can, if you see this here, this oxygen is replaced by the hydrogen, right? We can say this as a displacement reaction also. Okay, single displacement reaction also, right? This copper oxide plus hydrogen gives copper plus hydrogen, water molecule. Here this copper is already combined with the oxygen. Now it becomes copper. That means removal of oxygen takes place. Removal of oxygen means what? Removal of oxygen means what? Reduction. That means it is reduced. This copper oxide is reduced to copper. Right? Here the hydrogen is, now it becomes water molecule. So some addition of oxygen takes place. Addition of oxygen means what? Addition of oxygen means what? Oxidation. That means the hydrogen is oxidized to water. Hydrogen is oxidized to water. Okay. Yes. Okay. Now I will explain what is reducing agent and oxidizing agent. This copper oxide is reduced, right? Reduced to copper, right? Which one helps the copper oxide to reduce? This hydrogen, right? Hydrogen helps in the reducing this copper oxide to copper, right? So this hydrogen acts as a reducing agent. Reducing agent. It helps the copper oxide to reduce to copper, right? Likewise, this copper oxide helps the hydrogen to oxidize. From this copper oxide only it gains the oxygen, right? So it helps in oxidizing this hydrogen to water molecule, right? So we can say this copper oxide is a oxidizing agent. Oxidizing agent. Clear on this? So now difference between the reducing agent, oxidation is taking place means it acts as a reducing agent. Reduction is taking place means it acts as an oxidizing agent. Clear on this? Okay. We'll see one more example. Copper plus oxygen gives copper oxide, right? Can otherwise call this as combination reaction also, right? Here, which one is oxidized and which one is reduced? See, this copper becomes copper oxide. It gains oxygen. That means addition of oxygen. Addition of oxygen means what? Oxidation. So the copper is oxidized. Next, this oxygen is combined with the metal, right? Combined with the metal. So addition of metal is taking place. Addition of metal is what? Addition of metal is what? It is a reduction process, right? So this becomes reduced. Okay, this is reduced means it acts as a oxidizing agent. It helps the copper to oxidize. Okay, this copper is oxidized means it acts as a reducing agent. Okay, it helps the oxygen to reduce, correct? The addition of metal, right? Next, hydrogen sulphate reacts with chlorine to form hydrochloric acid plus sulfur. Okay, now we'll find which one is oxidized and which one is reduced. Okay, see, this hydrogen sulphate, right, is from this hydrogen sulphide the sulfur is removed, right? The sulfur is removed from this. Okay, removal of metal. Removal of metal means what? Removal of metal means oxidation process. Okay, this chlorine becomes hydrochloric acid. This chlorine gains one hydrogen, right? Hydrogen, that means addition of hydrogen. Addition of hydrogen means what? Reduction process. This chlorine is reduced. Clear on this? Okay.